everyone. So I'm going to be telling you a story about something I said once to one of my coworkers here at Clio several years ago at this point. I've been really meaning to write this talk for a very long time, about how experienced programmers solve problems and what that sort of means about how we communicate. So this is who I am. The little camera there has covered up some of my contact details. Apologies for that. I'm Fel. I've been working Ruby since 2012. I'm a staff engineer here at Clio, which means I sort of do whatever the company needs me to do, whether that's individual contributor work or sort of running a collection of teams, depending on the day, week, month, year. And I try and be pretty efficient with my time and my effort wherever possible. The thing that happened was one spring, about 3 or 4 years ago at this point, I was called over to help a coworker with a test that's failing. The developer in question has okayed these slides. It was years ago now. We are all different people, but it's worth mentioning that, like, she knows I'm giving this talk. She doesn't know why it's not working. It worked fine yesterday, and as far as you can tell, the failures that she's having don't seem to be related to anything she's changing. This is as much Ruby as you're getting. Enjoy it. That's all you're going to have. It's a mini test failure. So I said to her, "Oh, it smells like time," and I feel like that is a complete explanation. I feel like we don't need to go into any more detail about what I meant by "it smells like time." Like, time doesn't have a smell. That's not a thing. Maybe it does if you have synesthesia or something similar. But for me, time does not have a smell. It's not generally considered to have one. So, like, what do I mean by that? And that's a question that requires a little bit of introspection, a little bit of deeper thought about my own communication, my own thought processes. And what I answered was something along these lines. Like, this is an issue that seems like it could easily have been caused by something related to date or time. Like, I was told that it was working yesterday and it isn't now, and nothing has changed, but something has changed. Yesterday, it was yesterday, and it isn't yesterday anymore. It was the 1st of March. We've just left February. February, if you don't know, is an unusually short month. It is normally 2 days shorter than the other shortest months, other than on leap years where it's 1 day shorter. So stuff goes weird in and just around February, particularly with dates. These tests are collecting some income transactions together and expecting a specific number of them. I haven't looked at why yet, but I'm kind of assuming it's not just creating 3 transactions and then expecting there to be 3 transactions. There's probably some sort of window function, some sort of restriction that we're looking at. And a very common way to look at that is how many things are returned in a given date area. The test code wasn't freezing time. There's no uses of timecop that I can see. This is actually a little bit more Ruby here. Libraries like timecop can allow us to travel to or stop at a particular point in time, and we weren't using one in the tests. So here's what I've described, right? I've described considering the symptoms. There are thousands of different causes of bugs easily. Maintaining your list in your head, a list of all of the symptoms of these bugs. And then when you are in a situation where a bug is occurring, compare your situation to those causes until you find one that matches your situation, verify your code verify your understanding of the problem by altering the code that you're working with, and then apply the solution for this problem, assuming that you were correct. So this quite detailed list of things. And for this, I've sort of nicked Murray's slide from an earlier LRUG. Have you tried just thinking really hard about it and hoping that you solve it? Is essentially what I've proposed here. This was to do with understanding flaky tests and trying to answer why a test is failing under particular specific conditions. But that isn't at all what I did, actually. Or at least, like, it's not what I consciously did. Post fact, I might have believed that I had done that, or done something like that, but it isn't really what I did at all. When I'm trying to solve a problem, I'm not necessarily thinking exclusively in analytic mode. I am also reacting instinctively. I've been a developer for more than a decade. I've spent multiple years working in the bugs team at previous jobs. I have a good grasp on what kinds of things lead to what kinds of problems, and that grasp is not entirely cognitive, it is also instinctive. It is a part of my brain that I don't have like necessarily logical control over. So this is much closer to what actually happened inside my own experiences. I looked at the problem for like 5 seconds and my brain just kind of went, time. And so I listened to that. Like, I'm used to hearing my brain give me ideas of what could be going on in a particular piece of code. It felt like it was a time problem. So I listened to that. And then I tried to fix it as if it was a time problem. And it was a time problem. So it fixed it. That's what I did. This is much simpler. There's very little thought happening here. A lot of this is very automatic. It's easy to go through these steps, in part because they are a lot less rigorous than what I described. So in summary, this is my alternative suggestion. Have you tried not thinking about it at all and hoping that you solve it? This is what it feels like to have an intuition about what a problem's actual solution is. You don't need to put in much work, and it just feels right that the solution should be a particular shape. So if we sort of compare these two different kinds of problem solving that we've seen here side by side, expert intuition is really fast, it is automatic, and it is instinctive. It just happens. I didn't sit down and say, what instincts do I have about this? I just had a feeling. Analytical problem solving, on the other hand, is slow, it takes effort, but it is much more logical, it is much more rigorous, and you can really step through each of the things that actually affect a particular problem. There are pros and cons to each of these things. And this essentially corresponds to something called dual process theory, which is an idea about how human cognition works. The science is not an entirely settled thing on this. This isn't like definitely how humans work. Psychologists broadly think this describes all kinds of different things depending on who you ask. So I'm not telling you this is absolutely how things work. If you want to read more about this kind of thing, I recommend Daniel Kahneman's book, Thinking Fast and Slow. System one is our automatic brain. It is fast, it is instinctive, and it is emotional. Intuitions and biases and reflexes come from this part of your brain. They come from this part of you. System two is the analytical, effort, logical part of you, planning out a system. That's this sort of thing. Analytical problem solving and self-reflection, all of these things come from system two. What I've described as expert intuition, the sort of fancy word for what I'm looking for here, is recognition primed decisions. We describe 3 different steps to this. First of all, somebody doing a recognition primed decision experiences the situation. The first step is just being in a place and having inputs to your brain from your senses. You don't really have any control over this. This is going to happen. Then analyzing the situation. Again, you can do this logically, you can do this thinking it through. That's not what's happening in a recognition primed decision. And then you implement a decision based on the analysis that your brain has performed. You take action and react to your situation. This is like the exact same thing as I'm describing here. This is what I did. The downsides of recognition primed decisions is that they are instinct-based. Subtle hints can easily be overlooked, and similarities to past experiences are very much stronger than differences. Human beings are incredibly powerful pattern matching machines, and we are vulnerable to seeing patterns where patterns are not. Anyone who's gone to the bathroom in the middle of the night and been surprised that there's snakes in their house only to discover that actually they dropped a sock while they were putting away the laundry understands that like our brain will make connections to things that aren't necessarily there. Disagreements can be felt a lot more emotionally. You're not in a logical part of your brain, and it feels more about you than necessarily about the problem at hand. So if somebody says, I don't think you're right about that, it can feel like a personal attack rather than like a criticism of the way that you are trying to solve the problem. And the solutions can easily be simplistic. It can be very tempting to be like, oh yeah, I know exactly what's wrong here. And anyone who's half seen an error message, tried to apply a solution, and then discovered that actually the error message didn't really say what you thought it did, understands this particular instinct. So what is the problem here? I'm kind of just describing two different ways that human beings can be and two different ways that human beings can communicate and think. So that's where we get to the actual topic and title of my talk. Why accurately describing how we solve problems is important, avoiding being the cause of imposter syndrome. This is the actual point of this. Less experienced engineers have no experience yet with expert intuition. They haven't developed it. They will look up to and trust those who are more senior than them. When a junior engineer is given a list of things that could have been used to systemically solve a problem, they think that's what's happened. If they ask the question, how did you know that this was a time problem? And you supplant in your head the answer to the question, how could I have worked out that this is a time problem? You are doing them a disservice. They will think that you actually did those things, and what you're describing is much harder than what you actually did, and they will see that. They will understand that in order to do the analytical steps that you've described, they would need to be thinking 100, 1,000 times faster than they currently are about these problems, and it will feel inaccessible to them. It will feel like they can't learn to be that fast. You can't get 100, 1,000 times faster at problem solving. And for some people, this will form a really difficult emotional thing for them, particularly because they don't know what it feels like to have expert intuition about this particular topic yet. They may be familiar with it with other things, but unless we explicitly say, I have an intuition about it, here's some things that might have led to that, they're going to understand what you've said to be true because they trust you. And that's a really important thing to keep in mind. So what am I suggesting that people do about it? If you're a novice, I encourage you to remember that these instincts are things that you will develop in practice. They may feel magical and inaccessible to you right now, but everyone who knows how to program now did not know how to program at one point. Everyone who can solve a problem without thinking at one point has banged their head against a problem for hours, days at a time. And it is okay to try and ask people, how did you know this? And understand that they will be answering perhaps from how could I have worked this out rather than what they actually did. If you're an expert, if you're somebody who teaches people, if you mentor, I encourage you to try and describe accurately what you think. If you are making a guess about something, say that you are making a guess. It doesn't make it any less valid. It doesn't make it any less an appropriate way to solve problems. Particularly in high pressure, time sensitive situations, it can be really vital to be able to move this quickly. But you are going to have to introspect about how you came to a conclusion. You're going to have to be honest with yourself that intuitively you answered a problem and that you don't actually know why you thought that sometimes. Sometimes your answer to why did you think that is going to have to be, if you're honest, I'm not really sure, but I'd like to try it and see what happens. A more developed instinct is one where you can more easily understand where it comes from. But I think most people have familiarity as human beings with instincts that we don't understand and aren't necessarily closely familiar with. And as a human being, I want you to try and remember that instincts are pattern matching. They are fast and they are often simplistic. I want you to try and think twice whenever you have time to do so and acknowledge when you can't. If you are in a situation where you need to be moving quickly, acknowledge to the people around you that that's what you're doing. Acknowledge that you're just going to be making some mistakes. They're going to be making some mistakes too. And that those things are okay because they are a factor of the situation rather than a personal failing from anybody involved. An additional thing that I would really like to encourage people to do is if you're having an instinct and it's not something you've really experienced much before, I want you to try and listen to it. Practice that skill and it will develop. We get better at the things that we practice as human beings. And if you let yourself listen to the instincts that you have and try and interrogate where they come from, you will get better instincts over time. Your brain will learn from that information. If you're an expert and somebody says, oh, I think it's this kind of a problem, even if you know immediately that they are wrong, it is really important that they get the chance to stretch that skill, to build those instincts, because the positive reinforcement they'll get when they're right, the negative reinforcement they'll get when they're not correct, those things will be really valuable for them building this strength, this confidence that we want everyone that we teach to be able to have. There you go. that's my little talk. Do I have any questions?
My question is, can you ask this specific person, this situation, what is their role? Right? So at some point there was a confusion, right? The person saw how you solve the problem. So the means that they're potentially not capable of that. And I guess, and this is just my assumption, that you suspect that you made an assumption about their role, for example, to learn or to fix something. And that might, a student conversation towards your assumption. So my question is, did you ask that person what they want to achieve, whether they want to learn or to fix problem, or to understand how the whole works? And then that might help to push their education and their growth, which is eventually.
So the question is, did I ask the person in this story what sort of interactions they wanted, whether they wanted their problem fixed, whether they wanted to learn about the code in particular, whether they wanted to be taught a more general approach? We had a little bit of a talk about it at the time. They called me over with the goal to have their tests be passing. That's what they wanted. Part of my responsibility as a mentor and as a more senior person is to try and take opportunities for teaching where I see them. It can be challenging and difficult to ask to learn, and it can be really beneficial if you see an opportunity to go into a little more detail about why something is, to give that opportunity to somebody else, because by definition, the person who is being taught doesn't know the things they don't know, and they won't always necessarily be able to see the opportunities for learning that somebody more experienced has. It is really important that this forms part of a sort of trusting and respectful relationship, and that you aren't being patronizing or passive aggressive in the way that you communicate these things. I have a very good relationship with this person. We've worked together for years. We still work together. And I felt very comfortable saying, like, let's talk a little bit about like how I developed this intuition. And a lot of this presentation is things that I've built up thinking about this interaction that I had over years. I didn't say something nearly this intense to somebody first thing in the morning when they had asked me to come and fix their tests. I didn't give them a whole explanation of like different models of human thinking. I helped them to solve their problem with the test, and then I talked a little bit about how I just kind of had a feeling about it, and that's something that led to this. I think having that rapport is a really important part of this and really can't be undervalued. Having trust and believing in good faith that somebody is trying to do their best, whether they're learning or teaching, is a really important part of this being a healthy interaction.
Yeah, so one thing that we have on your answer, source of inspiration that reflection, and I think that might be because from what I heard, you inspired the person.
I hope so. This was a statement that I was an inspiration to this person, and I certainly think so. Like I say, we're very good friends, and we have been working together for a while. They will often come to me with questions about the internals of things. That's sort of my speciality, and it is definitely something that I care a lot about. It's important to me that this isn't a presentation about how good I am. This is a presentation about how everyone has the opportunity to be considerate and generous to people around them, regardless of their expertise, regardless of their skill level. And that's really the note I'm trying to hit here. Do we have other questions? Yes. Yeah, so 2 parts to that, one of which was it could be really interesting to talk a little bit more about the emotional aspect. You're not the first person to give me the feedback that this is an emotional part of your brain really strikes a chord. I think it's not that uncommon for somebody to experience frustration or other emotional reactions to a challenge when they're in that state, because it's a very natural and human thing to do. I personally found it incredibly helpful to understand that this was something that relates to me being a human being rather than something that is a failing of my personality or of my approach. And that similarly, if somebody else experiences this with me, and if I can see somebody getting frustrated, I can extend generosity to them and understand where they are and how to give them the space to calm down and to engage their rational thinking without essentially being like, I think you're getting really upset about this and there's no reason to, because that does not work. It will only make people dig in their heels most of the time, unless somebody is quite capable at engaging their logical brain and interrupting their more emotional brain. And not everyone has yet developed those skills. The second part of what you said, I have forgotten because I was talking for a little while there. It was about the in-between state between being a novice and being an expert, and how that can have sort of unique challenges. And I think that's a really good point, and that's sort of part of what I'm trying to say about like helping people to practice their expert intuition, is that is when you're starting to move from one state to another. I am definitely boiling a lot of things down here to overly simplistic. It is really important to try and get the sort of broad strokes here, but you are completely right that there is a whole spectrum of experiences here from novice to expert, and I'm certainly not at the far end of one of these experiences. There may well be additional learnings, additional things that are not accessible to me because I simply don't have the experience required to understand those things yet.
Thank you. Just to remind me and say what's in between novice and expert. There are two frameworks I find useful. One is from the Dreyfus brothers, who started it. They have, I think, 5 stages, probably world-class experts, and working through. And they work with it. And the other thing called kinetism, which is a word for spelled K-Y-N-E-F-I-N thing, which is a 4 quadrants plus fits in the middle, which you don't know, and that relates to the unknown unknowns, known unknowns, which is skilled on the end, which maps to the Dreyfus brothers thing quite well. So they include how to move. The Dreyfus one includes how to move to the next stage.
Okay, thank you.
Talk about intuition field. Got something in there.
Thank you. I really appreciate that. That was a summary of sort of 2 different models of understanding knowledge and experience on a particular topic, both of which I will definitely be looking up later. One of which is in Welsh, and I could not spell it again, but I'll get you to write it down for me later. Yes. Dreyfus, and the other one was Dreyfus Brothers. Have I tried writing my instinct as a TypeScript server so that we can solve the Thanatos problem using my brain? I don't super want the experience of any version of Fel to be living inside a TypeScript server and sort of having to solve code problems day in and day out. I quite like going home at the end of the day, so I'll probably opt out of uploading my brain into a computer for that particular purpose, but it's a fun idea for sure. Yes?
The instinctive reaction. Have you come across some versus nice that the project guess what the solution is? For example, type one, just wrap everything in a thing called feeds, which appears to work, but it's only just back all things, or just disable the Olympic is probably where does that or have people understand the teachings of trying to discover? Yes.
So the question there is about the difference between a instinctive guess at the solution and an instinctive understanding of the problem. I think you can definitely build these things as separate skills. Understanding this is a symptom of this particular kind of a problem often develops almost in sync with understanding what kinds of solutions need to be applied. And sometimes it depends how deep your solution needs to be. If I'm in a situation where production has fallen over and I need the servers to come up right now, I actually may not mind if they're going to come down again the next time that Friday the 13th happens to happen in a particular month. I have time to fix that. I need things to be working now. I don't need the solution to be the actual right solution. In the case of this particular thing, we did spend a little bit of time double checking that the behavior worked as intended, rather than this being a single instance where the behavior was not working as intended that happened to come about on the 1st of March. I think it is really important to interrogate not just what the solution you have come up with is, but whether there could be something causing these symptoms that is a real problem, rather than something that causes these symptoms that is a sort of more flexible answer to the problem. I think it can be dangerous to, and this is a more generalized testing philosophy point, but it can be dangerous to react to test failures that happen under certain conditions by ensuring those conditions don't happen in your tests, rather than interrogating whether those conditions could happen in a real environment and cause real problems. I think there was somebody behind the pillar who had a...
Yes, yes. I just want to point out intuition. Okay, not necessarily.
Yeah, I think it's very fair to say, intuition is not always an educated guess. It is something that is developed from pattern matching. Pattern matching can come from education and from repeated experiences in a particular area. It can also come from seeing the same things in the same place too many times and drawing incorrect conclusions. A lot of human biases, a lot of prejudices come from this part of the human brain, where things have been experienced together in the same place at the same time too many times, and people draw a connection causatively between those things when there is no causative connection between those things. People have just experienced the same kind of thing in the same kind of way, and it leads to really incorrect intuitions about the world and about how things work. I think that's probably enough questions.